Very good afternoon. Uh, okay, so I hope everyone hear my voice properly. Right. Today's class is about chapter 9. Chapter 9 name is Idea of Parallelogram and Triangles. Okay. Before starting our first topic you can see, our first topic is uh, we have to find out a figure on the same base and the same parallels. So basically we have to study few figures. Okay, we have to study the figures and we have to see whether they are on the same base or not. In the figure 1, what you can see in the figure 1 you can see, look, this triangle AXB, this triangle AXB and ABCD is a quadrilateral. You can see this triangle and the quadrilateral on the same base or not? Yes or no? They're on the same base AB, and this triangle and the quadrilateral are between two parallel line, that is DC and AB, right? So that is the thing, that the triangle and the parallelogram, not parallelogram, there is just a random quadrilateral, not to mention is parallelogram or not. It is between two parallel line. One is AB, another is DC. Okay. Now in figure 2, what we can see in figure 2? In figure 2, we can see that one triangle is there, that is PAR, and ABCD, one quadrilateral. Can anyone let me know, are this triangle and the quadrilateral are on the same base? In figure 2, let me know, the triangle PAR and quadrilateral ABCD are on the same base. Yes or no? I mean, what no? They are not in same base. My question is, two question is there. First question is, are their base are same? Second question, are they between parallel line or not? First question, are they on the same base? Or second question, are they on the same parallel line or not? No first. Okay. Anyone else? Let me know the answer. You can see this PAR triangle is not on the same base, because for ABCD quadrilateral, what is the base? AB. But for PAR, that blue color triangle, its base is AR. So the base is not same. But these two are on the same, are between same parallel line. Look, DC and AB are parallel. So PAR is between them, right? It does not matter that AB, and if AB parallel to DC, then it should be AR also and parallel to DC. So this triangle is between two parallel lines but not on the same base. Okay, figure 3, what we can see figure 3? In figure 3 we can see the triangle, you can see PYQ. The triangle is on the same base, and PQRS, this what it called quadrilateral, are on the same base, and they are between same parallel line also. Look, PQ and SR are parallel. Okay, and on the fourth figure we can see two triangle, one triangle and one quadrilateral is there, but they are not same base, they are not on the same base or same parallel line. Okay, so these are the four figure, different figure. So this is what you have to identify. I just want to give you small tasks based on this. I want to give you small tasks, The task is this: you have to, in exercise 9.1, just homework. You can see exercise 9.1, you have to identify the which base is that, okay, and you have to write the, yeah, exercise 9.1. If you see exercise 9.1, I'm giving this one homework. Okay, you have to just see whether they are on parallel, between parallel line and base or not. If that, you have to write. If not, you have to just ignore. So that one is very easy homework. Let's move on to the next topic. Basically, we start from the topic 2. That is very important topic. That is parallelograms on the same base and between the same parallel line. That is our topic 2, and that is from where our theorem will start. So theorem 9.1, in theorem 9.1 is saying that parallelograms on the same base and between same parallel line are equal in area. Parallelogram on the same base and same parallel line and between same parallel line are equal in area. You can see I draw one diagram here also. Okay, I just want to show you a little bit broader. You can see it, I just wanted to draw two two parallelogram. One is with a black bold one and another one thinner red color one, right? So A B C D one parallelogram and P A B C B Q is another parallelogram, and they are on the same parallel, same base. Look, this parallelogram both having base same AB and between the same parallel line PC and AB. Okay, now let start the theorem. We are taking that let ABCD and PABQ be two parallelograms. ABCD and PABQ are two parallelograms on the same base AB and between same parallel PC and AB. That what is given, that I just wrote. Okay, then we have to prove area of parallelogram. We have to prove area of parallelogram ABCD parallelogram area and area of parallelogram PABQ. That two things we have to prove. Okay, let's come to the proof. Proof part. Now we'll check these two triangle PDA, okay, and QCB. These two triangle. This two triangle. Okay, in this two triangle APD and BQC, this blue color things, blue color angle, I hope you all of you can see. These two are equal. Can anyone tell me why these two are equal? Why these two are equal? APD and BQC, why they are equal? APD, angle APD and angle BQC, why they are equal? I hope all of you are not sleeping. Please reply. Why APD and BQC are equal? The blue color in these two triangle, the blue color mark angle, why they are equal? No, I'm asking angles. APD. Check this angle. APD. This blue color angle and BQC. This blue color. This one. APD and BQC. Why they are equal? Any answer? that means not studying at all, that is corresponding angles. They are corresponding angle from, sorry, corresponding angles. Why? Because look, PA and QB are parallel and PQ is transversal. So we'll write from, because PA parallel to QB and PC transversal. Okay. Similarly, PDA, this angle, and QCB. Why they are equal? Because DA and CB are parallel and PC transversal. Okay, the green color one. Because here we have to see, it will be DA parallel to CB, DA parallel to CB, DA parallel to CB and PC transversal. Okay, now why PD equal to QB? Anyone? Why PD equal to QB? Sorry, not PD, PA. Sorry, not PD, PA. Why PA equal to QB? Anyone? Why PA equal to QB? Why PD equal to QB? Because opposite sides of parallelogram. Okay, few things have to remember, otherwise this geometry will be very difficult. Okay, so because you can see that PA and QB is the opposite side of parallelogram. I'm writing PA BQ. You can see the PABQ parallelogram, the thinner line. So here they are equal. Then what we can see? We can see, so these two triangles are congruent. By which congruency? Let me know. My goodness, what happened? By which congruency? Anyone? PDA, these two triangles, we proved they are congruent. By which congruency? These few things you have to tell, otherwise, I mean, like, this is like, what do you call? This will be very boring. I'm saying everything, but you are not studying at all. So it's like, yes, it is AAS. By AAS congruency. Okay, this is not ASA, because any two pairs of angles and one side. When it will be ASA? When two angles and then be in between side will be equal. But here PA and QB is not in between side. Okay, so that thing you have to remember. Now so these two triangles are congruent. If two triangles are congruent, we know that their area will be also equal. Look, I wrote here triangle PDA congruent to triangle QCB. So area of triangle PDA equal to area of triangle QCB, because we know congruent figures have equal area, right? So now what I will do, I will add area of trapezium DABQ. What is DABQ? DABQ, that means the middle area. DABQ, I'll add this area, same area, to the both sides. Okay. So we'll get, therefore, we'll get this one plus area of DABQ. Here also plus area of DABQ. Okay. So if we add, I'm just moving this one down a little bit just to show what will happen. Now area PDA this triangle plus DABQ. If I add, what I will get? If I add with the PDA this triangle, if I add DABQ area, what I will get? I will get area of PABQ. I'll get area of PABQ. Similarly, on the right hand side, with this triangle QCB triangle, if I add DABQ with this triangle, if I add DABQ, what I will get? I will get ABCD whole parallelogram. Okay, we'll get ABCD parallelogram. Okay, so this is also area of ABCD. Okay, we have to mention parallelogram. Okay, parallelogram, one shortcut, this one is this. This line is parallel and GM means parallelogram. So we can use this one also. Okay, hence proof. You can use this one, parallel line and GM on the superscript. It will all known as parallelogram sign. Okay, so that's what we have to prove. Look here, a parallelogram ABCD equal to parallelogram BAQ. So we already proved parallelogram ABCD, parallelogram PABQ is equal to parallelogram ABCD. Now, so any doubt regarding this exercise? Sorry, not exercise. This theorem 1, and based on theorem 1 only, we have exercise 9.1. So any doubt regarding theorem 1? Okay. Anyone else? Seems like beside Imli Jugla and Nocturnal, everyone is sleeping. No one used to reply anyone. Okay. Then move on to the exercise question without delaying. Exercise question, first question is saying, in this page number 100, and if you having the book, you can open 172 page number. Question number 1 is saying ABCD is the parallelogram. You can see ABCD is the parallelogram ABCD, where AE is perpendicular over DC. Okay, is perpendicular over DC. Then CF perpendicular over AD. If AB length is given, AB is 16 given, AE length is 8, and CF length is 10. We have to find AD. AD means this length. Okay, So few things is given, which is given ABCD is a parallelogram, and these are perpendicular length, perpendicular also given, perpendicular length also given, AE given 8, CF also given 10, and one side is given 16. We have to find the other side of the parallelogram, that is AD, AD or BC, anyone. Okay, so for this what we have to do? We have to just, I am just for the writing here, there is no given or something like that, because we have to find the value. So we are writing like this solution. We have AE perpendicular over DC. In the question it is given AE perpendicular over DC, and AB length is given 16. Now AB and CD are same length because they are opposite side of parallelogram, right? So if AB is 16, CD also 16. Okay, now area of the parallelogram. What is the area of a parallelogram? I hope some of you know. Area of parallelogram formula. Area of parallelogram formula is base into height. Okay, area of parallelogram formula is base into height. So area of ABCD parallelogram will be base into height formula. Now, if we consider CD as the base, if we consider the CD base, then we'll consider the AE perpendicular or AE height. Okay, when we consider the AD base, we'll consider CF as the height. Am I clear? You can't take CD and CF together. You have to take the base, and height means the length between the parallel lines. So when you take CD, what is the distance between parallel line? That is AE. So when CD is the base, height is AE. When AD is the base, height would be CF. So now concentrate on the CD and AE. So area of the parallelogram, we got height into base into height, which is CD into AE, and CD value is 16, we put as 16, and AE value we got 8 from the question, and this is equal to 128 centimeter square. Okay, so just for mention, it is given that AE is 8 centimeter. Now let's move on to this question. Since CF perpendicular over AD, as I told, when we'll take CD AD as a base, okay, then CF will be the height. So area of the parallelogram of ABCD will be AD into CF. Considering AD as a base, CF will be the height. Okay, now we already got area of the parallelogram is we already got area of the parallelogram is 128 centimeter square. So we'll write here, sorry, not centimeter, it will be centimeter square. We'll write here AD into CF equal to 128, because we already got area of the parallelogram is 128 centimeter square. Okay, then we just put the value of CF value is 10. So AD value from here we got what, 12.8, that is the value of AD. Okay, so this question is very easy. Sometimes it used to come for 2 marks. Very easy question. If you just know the what is the area of the parallelogram, you will do this one. Okay, next question number 2. Question number 2 is the important question, very important question. Question number 2 is saying if E, F, G, H are respectively the midpoints of the side of a parallelogram. You can see I draw one diagram. In this diagram you can see E, F, G, H are the midpoints of AB, BC and DC. Okay, now what we have to prove? We have to prove area of EGH equal to half of area of ABCD. Area of EFGH, this, if you join all the midpoint you will get this one. Okay, we have to prove these are the half of the ABCD. So before that, let's write down the given part. In the given part we have to write this. Okay, and we have to write this. Here we given part we have to join this one. Okay, in the given part we have to write this one. Then we join GE, where GE parallel to BC and CA. Look, if they are on midpoint, okay, if we join, they are midpoint, right? E and G are midpoint. So if you join, it will be it will always parallel to the BC, the other two sides, BC and AD. Fine. What you have to prove? We have to prove that this, that area, this one equal to this one. We have to prove that AR means area. I hope all of you know area of EFGH equal to area of EFGH is equal to a half of area of ABCD. Okay, so just for the this is the this is the theorem we learn. I just wrote because in exam time you don't have to write. Okay, for just to remind you what theorem we learn, that if a triangle and a parallelogram are on the same base and between same parallel lines, then the area of the triangle is equal to half of the area of parallelogram. This theorem we learn, right? Now come to the main. In exam time you can just skip this what you call italic one. Okay, you don't have to write. Now ABCD, EGH, triangle triangle EFG. I hope you can see EFG. Okay, is a triangle, and parallelogram EBCG. EBCG is a parallelogram. Why? Because in this one EG parallel to CB, okay, and GC parallel to EB, right? GE already parallel to CB by construction, not construction, by from the given part, okay, and obviously GC parallel to EB. You don't have to write, okay, you can just mention this one here. Yeah, in the given part you can mention once. You can given part you can just mention therefore EBCG and EGDA or AEGD are parallelogram. So EBCG this and AEGD are parallelograms. Okay, that's so mentioned so that we don't have to mention here. So now concentrate these two triangle EFG. Okay, EFG, this triangle EFG and parallelogram EBCG are on the same base EG. Okay, and between the same parallel line EG and BC. Therefore, area of EFG triangle is half of area of EBCG. Okay, so mark this one number 1. Mark this one number 1. Similarly, EHG, this is also between AD and AD and EG parallel line and on the same base EG. That means you can see EHG is half of AEGD parallelogram, right? Similarly, you can write this is number 2. So from 1 and 2 or adding 1 and 2, we'll get I'm adding 1 and 2. What one? This part, this one and this part. So I'm adding area of EFG, area of EFG and area of EHG. I'm adding on the left hand side and right hand side area of half of area of parallelogram EBCG and half of parallelogram area of AEGD. Okay, so what we are getting on the right hand side and left hand side? Right hand side we will get, let me complete three things. One here. Okay, right hand side what we got, just check once. We got half of area of EBCG and half of area of AEGD. When you write and with the diagram you will understand completely. Okay, you can see half of this parallelogram and half of this parallelogram, and we already add half of this triangle and half of this triangle. So I just took half common. Okay, I just took half common from both. So what we are getting, half of area of parallelogram EBCG and half of area of not half of area of AEGD. So left hand side what we will get, area of EFG and area of EHG triangle, total making area of EFGH. Okay, EFGH quadrilateral. And on the right hand side, if we add EBCG and AEGD parallelogram, what I will get? I will get ABCD parallelogram or ABCD quadrilateral, you can say. So that's what we got. Look here. Thus EGA EFGH equal to half of area of ABCD. Hence proof. Hence proof. This is very interesting proof and very important also. Okay, question number 2. In question number 3, saying P and Q are 2 points lying on the side DC. Okay, and AD. You can see P and Q 2 points. P lying on the DC line and Q lying on the AD line of the ABCD parallelogram. We have to prove area of APB equal to area of BQC. Okay, that's what we have to prove. So given part, in the given part it is saying ABCD is the parallelogram. ABCD is the parallelogram given. So if parallelogram, then opposite sides are equal. Opposite sides are parallel. So we wrote AB parallel to CD and BC parallel to AD. Okay, then we are just mentioning P and Q are any 2 points lying on DC and AD respectively. DC and AD respectively. Okay, we have to prove that APB, area of APB triangle and area of BQC triangle equal. That's what we have to prove. So triangle APB and ABCD parallelogram are on the same line, same base AB, and between same parallel line AB and DC, right? Therefore APB will be equal to half of ABCD parallelogram area, right? That's what we learn in theorem 9.1. So we wrote area of triangle APB equal to half of area of parallelogram ABCD. Similarly, BQC, this triangle and parallelogram ABCD on the same base BC. Look, BQC triangle are on the same base BC and between the same parallel line BC and AD. Okay, and AD, BC and AD. So therefore area of BQC is equal to half of area of ABCD, half of parallelogram ABCD. So from number 1 and 2, what we can see, both is equal to the half of area of ABCD parallelogram. So from number 1 and 2, we got area of APB equal to area of BQC. That's what we have to prove. Hence proof. Okay. This is the question. P is any point interior, and we have to show that area of APB in this triangle, upper triangle, plus area of PCD is equal to half of area of ABCD. This triangle APB plus PCD equal to half of ABCD. Okay, then and we have to again prove that area of APD plus area of PBC is equal to area of APB and area of PCD. Very easy. Let's start. Let's start. We will not write anything. We will just do one construction. I mean, sorry. We'll yeah, in the given part you can just write this. P is a interior point in the interior of a parallelogram. Okay, and ABCD. Therefore, that is, so you can write therefore AB parallel to CD. Okay, ABCD is a parallelogram, so it will be there. And let us draw this one. Let us draw EF. Oh, I have to write EF, which just wait a minute. And we'll draw this, that EF parallel to AB and EF parallel to AB through P. EF parallel to AB through P. Okay, that's what we have to prove. I mean, that's what we have to write. Then I think we have to draw another part also, which okay, wait, we have to draw another part also, which we have to draw. Well, this is our perfect diagram. Okay, sorry for this one. So we have to draw two line. One is EF parallel to AB and one is HG which is parallel to AD through P. Then this is what we have to prove. This part we have to prove. Okay, let's start the proof without wasting the time. For proof, first part, we have parallelogram ABCD. Okay, now APB, where is APB? APB, in APB and parallelogram AEFB, okay, are on the same base and same parallel line. If you see this one, I will show you. Which line? APB. Okay, APB is a triangle, is on the base AB, and AEFB is a parallelogram. Why AEFB is a parallelogram? Because look, EF parallel to AB, right? And obviously AE and BF was parallel, so AEFB is a parallelogram. So you are right here. uh, Triangle APB and parallelogram AEFB is on the same base AB and between same parallel line AB and EF. Therefore, area of APB equal to half of area of AEFB parallelogram. That is number one. Similarly, PCD, this down one parallelogram and parallelogram and parallelogram CDEF, this parallelogram on the same base CD and between same parallel line CD and EF. Therefore, triangle PCD is half of area of parallelogram CDEF. Okay, so just wait a minute. Have to sit. So from 1 and 2, what we can get? If we add 1 and 2, we'll get 1 and 2. From 1 and 2, if we add the left hand side, it will be area of APB plus area of PCD. Okay, that's what you are seeing. And here you will get half of area of parallelogram AEFB and half of area of parallelogram CDEF. Okay, so left hand side, if we take common half from the right hand side, we'll get if we take half common, we'll get this. Okay, which is equal to Next line, which is equal to half of area of ABCD. Area of ABCD. Okay, I hope you can understand this parallelogram AEFB and parallelogram CDEF. If you add, we will get area of ABCD parallelogram. Basically, that is the parallelogram. Fine. Next, so this is our number one proof. Okay, it's okay. Let's mark this one now. This one, mark this one 1, this one 2, this one 3, 1, 2. So our number one proof done. Okay, number one proof done. Now for number two, I'm copying the diagram here also. Okay, I'm copying the diagram here. Now in triangle, triangle triangle APD and parallelogram ADGH. I hope you can see APD triangle and parallelogram ADGH. Okay, are on the same base AD and between same parallel line AD and HG. Okay, so area of APD will be equal to half of area of parallelogram ADGH. Okay, parallelogram ADGH. Fine, that is number 4. Similarly, we can write this one also. Similarly, we can write area of PBC. PBC is half of area of BCGH, because PBC triangle and BCGH parallelogram are on the same base BC and between same parallel line BC and HG. Okay, that is number 5. Now we'll add number 4 and 5. We'll add number 4 and 5. So number 4 and 5, if we add, we'll get this. We'll get APD. Left hand side, nothing will change. Left hand side will be APD plus PBC. Left hand side APD plus PBC. These two triangle adding. Now right hand side it will be half of parallelogram this and half of parallelogram BGCH. Okay, half of ADGH and half of BCGH. Okay, now if we add this one, similarly we'll get this ADGH plus BCGH will be ABCD parallelogram. Right, mark this one 6. From 3 and 6, where is 3? 3 is this. 3 we got area of APB plus area of PCD is equal to half of area of ABCD. And on 6 we got area of APD plus area of PBC is equal to half of ABCD. So from these two we can write APB plus PDC equal to APD plus PBC. Okay, that's what we wrote here. Area of APB plus PBC equal to area of APB equal to PDC. Fine, that's what we have to prove. That is number 2. Right, hence. Okay, do one thing in this one. I hope if someone having problem, I always record every class, and so do one thing after the class when the recording will be up na, after copying just see again. Okay, you'll understand more. If you having any doubt regarding in mind after copying, and if you see this class video again, the doubt will clear. Fine. Then today's class is up to this. You can just send me the roll numbers now. Okay, I have to record once one thing. Yeah, bye everyone.